Hello, fellow Java developers. Welcome back to our making an example of a real-world Apache Camel Application series. In this video, we will add a global error handling to our routes, and we will write an integration tests for our whole application. Let's begin. We will start from the overview of what we have already and what we need to add. As you can see, this is the diagram of our data flow, and we've already implemented all of the main operations: reading from a SFTP server, sending a request to and receiving a response from an HTTP service, and sending a request to and receiving a response from an MQ service, and we've added logging of each step into the database. What do we miss though is logging possible exceptions in our database. As you can see, our database log table has this error details column, meaning that if our application gets an exception, we need to write its details here in this row. So we will begin with doing exactly that. As you might remember from our Apache Camel Beginners series, and in particular error handling video, we have several ways of configuring an error handling for multiple routes. In this application, the error handling logic will be the same for every route. This is why we will go with a default configuration approach. We will create a global configuration class, and in that class we will specify our error handling logic, which will be writing an exception details to the database. So to create camel route configuration, we need to extend route configuration builder class and implement its configuration method. Inside the method we need to use route configuration static method, and here we will specify on exception, and we will catch every unhandled exception. So we're specifying exception class here in this on exception DSL element. Then, after we've done that, we need to decide if our error handling logic will be marking our exchanges that caused the exception as handled or not. Here we are specifying handled false because we want our error handler to handle the exception after we write the exception details into the database. In particular, we want our SFTP endpoint error handler to be able to move the initial file to the error folder. This is why we're marking our exchange as not handled, so that the error handler configured here with this move failed option picks up the exchange after we've written exception details to the database and moves an initial file to the error folder. Now we have two possible options. First option is that we get an exception before we even write an initial log to the database, indicating that we've read the file. In this case, we don't want to write anything to the database because we might even not have all the metadata required to make this insert statement. But if the exception happened after we've inserted our log entry to the database and got an ID header, then we want to update this inserted log entry with the exception details. This is why in our condition we're checking that the header containing our log entry ID is present. For that we'll use object_utils is empty method, and we will extract the header from our exchange with getMessage, getHeader methods. And here we need to specify the name of the header and its class. Let's do that. And after we've done that, we can specify our logic. So this condition checks that our message has this database log ID header, which means that the exception occurred after we've inserted an initial log entry in the database. This means that in this branch of execution, we need to specify logic that updates this inserted log entry. For that, we will use an SQL log endpoint, similarly to what we have in our routes that update our log entry in the database. And in the SQL endpoint itself, we need to specify that we want to set the error details field, and as a value of that field, we will use exception.message. This simple language expression will call getMessage method on the exception that we've caught here, and the result of that getMessage method will be written to the error details field of the database log entry with the ID that we've specified here. So basically what this error handling logic does, it checks if we've inserted a log entry into the database, and if we did, then it updates that log entry. And if we didn't inserted the log entry yet, we don't do anything because we might not even have the metadata to insert that initial log entry. Now, as we've specified our route configuration, which will be auto-discovered by Spring because we put this component annotation, and we want our route configuration to be applied to each route in our context, we simply don't specify a route configuration ID, and in our routes, we also don't specify a route configuration ID. This will result in this error handling configuration being a default route configuration in Camel context, and thus it will be applied to each of our routes automatically. Now, when we created our error handling configuration, we need to test it. We will start from unit tests. Basically, what changes in our route logic and consequently in our unit test is that we need to check that in case of the exception, our error handling configuration will work as expected, meaning that if our message has this database log ID header, then we will get a message in this SQL log endpoint, and if we don't have this database log ID header set, then our SQL log endpoint does not receive any messages. So we will start with read document route unit test, and here what we will do is we will add mock on exception SQL endpoint, and we will call it mock on exception SQL. Of course, we will inject it same as other mock endpoints. And now when we have it, we need to, of course, replace this endpoint, which we can do with the same replace endpoint method. And here we will specify our error handling configuration SQL log endpoint, and we actually need to get its URI, and our mock exception SQL. Now, after we've mocked our error handling SQL log endpoint, we need to specify our expectations for that endpoint. And here we're expecting it to have 0 messages. And let's actually use our route test utils and check assertion satisfied method to pass all the endpoints here, and don't call assert is satisfied method multiple times. Here we can delete it, and also we need to delete this. Here we're setting the expected message count to 0 because, of course, in the case that no exception occurs, our SQL log endpoint specified in error handling configuration should not get any messages. And after that, let's run our test to ensure that we did not blunder anything. And as you can see, it runs normally. Now, what we also need to add is a test case when there is an exception in our route. So let's call this test case read document route exception test, and here in the test we'll do everything the same, but this time we will configure our file metadata extractor mock in such a way that it throws an exception. Let's actually call it expected exception when we want to extract our file metadata. And here we will specify any. And as our error handling configuration does not set handled true, we can use assert throws to ensure that our route actually throws an exception. So after doing that, we just need to take all our mock endpoints and ensure that none of them received any messages. Even our mock on exception SQL should not receive any messages, because again the exception happens at this stage when we extract our file metadata. We haven't inserted anything into our database yet. This means that we haven't set our database log ID header, which means that here in this choice element the condition will be false, and again we will not send a message to our SQL log endpoint. And after we did that, what we also need to do is we need to reset our mock endpoints here in this before each method, because they will retain their message count, headers received, etc. from the previous test if we don't reset them. For that, let's go to our route test utils, and here we will add reset endpoints method. It will be very much the same as our check assertions satisfied method, but of course here, instead of checking that assertions are satisfied, we will just call a reset method. This way we will be able to just call reset mocks and don't write mock endpoint.reset multiple times. So here let's rename our method, and after we've mocked everything, let's just call route test utils reset mocks, and we'll pass all our mock endpoints here. And now we can run our test to ensure that everything works as expected. As you can see, we didn't blunder anything, which means that we can test similar logic for remaining routes. The only difference will be that, of course, their exception test case should actually send message to mock error endpoint, because these routes are receiving messages with database log ID header set. I will edit out creating these test cases and just show you the results. And here we have it. We did a similar thing in send document route test and sign document route test. We've added mock on exception SQL endpoint. We've replaced the SQL log endpoint from error handling configuration with our mock, and then we've added a new test case where we're making our bin that our route uses to create message to throw an exception. And then we're checking that our SQL endpoint from our error handling configuration received a message. And of course, we've added this reset mocks method call so that mocks do not store their received messages between tests. And it's the same in sign document route test. We've added our mock endpoint. We've replaced an SQL log endpoint from error handling configuration with that mock. We've added a test case where our request mapper throws an exception, and we're ensuring that only our SQL endpoint from error handling configuration received a message. And of course, here we've also added a reset mocks method call. Now what we should do is we should test our error handling configuration in an integration test. But as we've tested it already in our unit tests, there is not much reason to test it in route integration tests, because what we will do is we will create an integration test for the whole application, in which we will also test our error handling logic. Let's call it document sign application integration test. And for that test, of course, we will need all the annotations that our integration tests have, but of course we don't want to exclude any routes. And the next thing that we need to do is we need to add all the containers that we have in our integration tests, because we will need all of them. And while we're at it, let's also move this SFTP container configuration to our test containers configuration class. It will be public static SFTP generic container, and the method we will call get configured SFTP container, and we will return a new generic container, basically the same configuration that we have in our read document. And here we will call this method. And now what we can do is we can just copy this container's definitions to our new application integration test, and we can do the same from our send document route test, because we will need the same Artemis container for our whole application integration test, and the same with sign document route integration test. We can just use its max server container. And by the way, let's also take this max server client, because we will need it. And now when we have it, let's add other things, but before we will just move this max server client below all the containers, so that all the containers are defined on top and it's consistent. Now that we have our containers, what we can also do is we can, of course, auto-wire camel context and producer and consumer templates, so that we can send and receive data. And after we've done that, what we also need to add is this mock client send service, because we'll need to check that our application actually sends messages to the external client send service, the same way we're doing it in our send document route integration test. And the last thing that we will auto-wire will be object mapper, because we'll need it to configure our mock server response. And of course we will need to create our dynamic property source annotated method, because we have several containers and we need to set up properties of our application in such way that it connects to the containers. So what we'll do is we will go to our read document route integration test, and we will not copy that, but what we'll do is we will create another method in our route test utils. It will be similar to our previous method that set properties, and it will be called set test SFTP server properties. And here what will we need to pass is a generic container called SFTP container, and as we've used test constants, everything else stays the same. So now let's actually call this method in our read document route integration test, and also in our whole application integration test. Here, of course, we need to accept a dynamic property registry, and now we have our property set for SFTP connection. The next set of properties that we need to set are these client send service properties, and let's also make it consistent with route test utils. static method calls. And the last set of properties that we need to send are the properties that are set in this set test sign document service properties method call. So we will also copy that. And let's see if we forgot anything. Let's actually add route test utils here to be consistent in our style. And what we also need to do is, of course, we need to wait until our containers start and configure a mock server client. Let's do that before setting our properties, but it doesn't make much of a difference. Of course, we need to wait until containers start before everything else, but after we ensure that containers are started, then we can do this in any order. And now in our before each method, we need to do two things. First of all, we need to configure our mock client send service in the same way as we're doing it in our send document route integration test, and we already have a method for that. And the second thing that we need to do is we actually need to clear our database, because we'll have several integration tests. Each test will be writing some kind of log into database, and it's just easier if we clear our database before we start our test. We will pass a producer template to this method so that we can use it to actually clear our table, and to do that we simply make use of sendBody method, and in our endpoint we will specify delete query. Let's copy the name of our table, and as we don't need to pass anything to this delete query, we will just specify a null body. Now, after we're sure that our log table is clear at the start of each of our integration tests, we can start writing the tests themselves. First, our test will be a positive scenario. We will just send a valid file and ensure that it passes through all three of our routes normally. To do that, we will take the creation of our request and response objects, and we will use them to configure our sign service response, because we'll need it to answer to our HTTPS request. And after we've done that, let's actually copy all the parameters from our read document route integration test, because that's the parameters that we'll need to send our initial file. And with all of that configured, we can start our test by putting a test file to the SFTP server from which our application will read it. And after that, all we have to do is wait until, for example, client send service receives the message. And of course, to check that we've received a correct response, what we need to do is we need to parse it. For that, what we'll do is we will first extract a list of exchanges that were received by our mock client send service mock endpoint, and for that we'll use mock client send service dot get received exchanges, and then we will again assert that we have exactly one exchange received, and let's actually rename it to exchanges. And when we've done that, we can actually get our send document response object that we've sent. For that, we will inject an XML mapper that we have auto-configured, and our client send request that we've sent to our mock client send service will be called actual client send request, and we will get it by using xmlmapper.readValue method, and as our value we will provide a body of the message of the exchange that our mock client send service has received. And of course we need to provide class to which our XML mapper should parse And after we've done that, we can just use assert equals to make sure that our request was constructed as expected. Here we have all the fields, for example, client ID. In the same way, we will check owner ID, and in the same way, we will check document ID. But when we will be checking our document itself, we will need to make use of this expected response, because that's the response that was sent to us by sign-in service, and this response contains the signed document that we should forward to our client send service. And the last field is a timestamp, and we will just check that it is not null. Of course, we could have checked that it is bigger than the timestamp that was initialized during our test. But for this simple unit test, we will just go with asserting that this timestamp is present. While our test is not finished yet, because we need to check our requests to all other external systems. We can check that it works already. Let's try to run it. And we have an error that our dynamic property source annotated method should be static. So let's make it static and run our test again. And as you can see, our test runs normally, which means that we haven't blundered anything yet. So let's continue checking other external systems. What we will also check is that our mock server received a correct HTTP request. For that, we can go to our signed document route integration test, and from here we can just copy the same mock server client verify call and use it in our application integration test. And it's the same with the database results. We can acquire them and then check that all fields are set correctly. And of course, apart from owner ID, we need to check a document ID. So let's do that. And after we've checked our log in the database, the last thing that we need to check is that we have a file in done directory, and that it is the same file that was uploaded to the server initially. Because as you probably remember, in our read document route, we've configured our SFTP endpoint in such a way that after the processing of our file is finished, we move it to done directory. So let's rename it to actual file from done folder. And here we've already replaced error folder with done folder. What we will also do is we will check that the file is not null and it has same file name and contents as our initial file. So let's go to our service documentation, and here we can see that we've checked everything. We've checked that we're sending a correct HTTP request to our signed document service via using mock server client verify. We've checked that we're sending a correct client send request over MQ by checking the mock endpoint that we have in the mock of our client send service. We've checked that we have a correct log in the database and that the file is moved to the done directory of the SFTP server after processing. So let's return to IntelliJ and run our test to ensure that we don't have any errors. And as you can see, our test runs normally, which means that we've set up everything correctly. Now, I should say that it's a lot of code for just one integration test. And if we were writing more integration tests like this, of course, most of this code should have been refactored. For example, we have this getting database results repeated in several tests. We have our expected requests and mock responses objects configured same as in others integration tests. All of this should have been refactored to be in a separate functions. But as we have only single integration test and the second one will not be so huge, for now we will leave it as it is. And we might return to refactoring later. So the next test that we will write is the integration test for our whole application that tests our error handling logic. For that, we will configure our environment in such a way that one of our routes throws an exception. And then we check that the details of this exception are written to the database correctly. So we will cause an exception by not setting up our sign document service mock, meaning that we will not create expectations with our mock server client for this test method. And in this way, all that remains to do is to send our file to this FTP server and wait for our route to fail. Then we will check that we have our initial file in error folder, same as we did in our read route document test. But the most interesting part is that we will check that our database contains a log entry with the exception details. So what will we do is we will check all fields of our database log entry. But instead of this status, we should have status set in our read document route, because it's the last route that successfully processed our document. So let's actually make it a constant so that we can reuse it without duplication. And we will call it read document status. And now we can use it both in our SQL string and in our integration test. And of course, the most interesting thing is which exception message do we get from our error details field. For that, we can for now just specify an empty string, then run our test to ensure that it behaves as we expected to. And then it should fail on this step, and we will see what message do we get from our exception. So let's run the test. And as expected, we've got an error, which is HTTP operation failed with status code 404. Of course, because we haven't configured our mock server expectation. So basically what we need to do is we need to construct this string and put it here to be sure that our exception message is written normally. So we will create a string that will be called expected error details, and we will construct it by concatenating this HTTP operation failed invoking string. Then we will get our mock server container secure endpoint. Then we will concatenate it with our service path that we hopefully have in our test constants. And if we don't, then we should add it, but we have it here. This is sign document sign path that we have here. And lastly, we will add this with status code 404 string to complete our error detail string. And now we can put it in our assert statement. And in this way, we can be sure that our error handling logic works and it actually writes the exception message to the database. Now let's run both of our tests to ensure that they both run normally. And our tests fail because we actually first of all forgot to reset our mock server client, and in our regular integration test it results in the client registering our request twice, and the test fail as we have specified that we should have exactly one request, and in our exception test we just have an extra space in our expected error details string. So with these fixes, let's run our tests again. And as you can see, our tests run normally, which means that our application works as expected. And just to be sure that we didn't blunder anything, let's run the maven test command that will run all the tests that are present in our code base, and we will look at the results. And as we can see, all our tests run normally. And with that, here is the end of our video on making an example of a real-world Apache Camel application. In this video, we've configured a global error handling logic for our route, tested it, and we also wrote an integration test for our whole application. In the next video, we will dockerize our application and write Docker Compose with all test environment required. Thanks for joining, be sure to like, subscribe and hit that bell icon. And if you have any comments or questions, leave them down below. I will answer to all of those. See you in the next video. Until then, happy coding!